Hello everybody, and welcome to the third video in this series where we will start actually working on our project and building out part of the backend. Now, as a reminder, the project we're going to be building is a rock, paper, scissors challenge application. What I want to do right now is just hop over to the blackboard, whiteboard, drawing tablet, whatever you want to call it, and give you a little bit of a high-level overview of the project architecture, just so that as we start going through the code, you have a better sense of exactly what it is that we want to do. Now, let's just start with the kind of objective of the project. We're going to have two players or potentially multiple players, but for now we can just stay with two. And these players want to play rock, paper, scissors against each other. Now, one player needs to initiate something called a challenge. Well, that's what we'll call it, so I'll just represent that with C. The other player then needs to accept the challenge, and then these two players need to reveal what it is that their answer is, right? So whether rock, paper, or scissors. Now, the challenging part comes in making sure that one player does not have an advantage over the other player when they reveal these answers. So just to quickly recap, player one, which could be this guy, creates some kind of challenge, and then player two, who we can call this guy, will accept the challenge. So we have challenge created, challenge accepted. Now, once the challenge has been created and it's been accepted by another player, at this point, both players should have already submitted what it is that they want their answer to be. So in this case, maybe this guy does rock and this guy does scissors. Now, if that's the case, we know that player one is going to win. The issue is, though, if player one were to create the challenge and submit rock immediately, and we were to just store that normally on the blockchain, player two would always be able to win by looking at what is stored on the blockchain for this particular challenge. Remember that any data we put on the blockchain is completely visible and transparent to anyone, so we need to do this in a little bit of a different way. So I'm just going to walk through how that process is going to work, and this is going to really inform how we go about writing this backend, which I won't lie to you is a little bit complex, but it's all kind of part of the tutorial to show you how this works. So the basic idea is that we need both player one and player two to make a commitment to a specific decision, so whether rock, paper, or scissors. However, we don't want that commitment to be revealed to the other player. So what we're going to do is use a little bit of a hashing technique, which is very popular in cryptography. Let's say player one decides that they want to choose rock. Now, they're the ones that are actually creating this challenge. So they say, okay, I'm going to create a challenge. I want my decision to be rock. So what they're going to do is with this rock decision here, they're actually going to append to this a secret code or something that we refer to as a nonce. Now, a nonce is just some kind of random number. We could say that this number is something like 173. Now, this secret number right here, the player is going to store, they're going to keep track of, and it's kind of like their password. Now, what they're going to do is they're going to take this whole value, so whatever their decision is, in this case it's rock, plus some random number, and they're going to pass it through something known as a hash function. Now, what the hash function is going to do is it's going to spit out some random value that we don't know how it was generated. So we're essentially going to get this kind of random string, and this random string is essentially the encoding of their choice and their random number. Now, just to simplify this quickly, the only way that we'll be able to get this same random number is if we were to pass in this exact input that we have in the hash function. So what that means is that this kind of value right here, so their choice plus their random number, is the only possible input that's going to lead to this output. We'll talk more about this in depth in 1 second. Now, the idea is we're going to store this value on the blockchain, which is the hash of their choice and their random number, otherwise known as their password. So we take this value and we store this on the blockchain. Now that that's stored on the blockchain, they've effectively committed that this is their choice, rock. However, they have not revealed that choice to player two because all player two is going to see is this hash. So now what will happen is player two will do the exact same thing. They'll have some decision. Maybe they go ahead and say, okay, I want this to be rock. And then they choose some random number, something like 373. Now, same thing here, they store their random number over here. Obviously, these numbers would be much larger. We're just using small ones for now. They generate a completely different hash, so maybe something like A, B, C, 1, 2, 3, just a random example, and then they submit this hash to the blockchain. At this point in time, both players have stored their secret password, and they've made what we're going to call a commitment, which is associated with this challenge. Now that these commitments are on the blockchain, they've effectively locked in their answer, but neither player knows what the other player's answer was because they don't have access to this secret code. So now what we're going to do is once both players have submitted their values, so let's just imagine we have kind of a check mark here and a check mark here indicating that we've made the decision from player 1 and we've made the decision from player 2, each player in turn, or in whatever order they want, is going to reveal their answer. Now the way they'll reveal their answer is actually by doing the opposite of what they did when they committed to it. What that means is they're going to take their secret code, so a value like 173, and they're going to take their decision. So I think this player, I forget what we did, but let's say it was scissors, doesn't really matter, okay? They're going to take these two values, and they're actually going to submit these to the blockchain. Now what's going to happen is on the back end, we're going to take the hash of these two values, and we're going to check to make sure it matches what they sent us before. So we're going to say, okay, we've got some string that we've stored, which is your commitment, which is the hash of your decision. Now that both players have made their decision, we're going to take the hash of whatever you tell us your decision actually was and your secret number, and we're going to see if that matches the hash that we stored. If it did, that means that you have now revealed your answer because you've actually submitted this data to the blockchain, which is your answer, and we verified that this answer is the same as what you originally chose. Again, I'm going to elaborate more on this, but that's the basic idea. Now, both players are going to do that, and when both players do that, that will effectively reveal their answer. Again, I forget what we did, but let's say this guy was scissors and this guy was rock, then we know rock wins. So it's a two-step process. They start by committing what their answer will be and kind of hiding this secret code, which would allow us to reveal their answer. Once both players have made this commitment, now it is safe to reveal the answer because these players can't change their commitment. They can only essentially reveal what it was. So now we go through the reveal process, and what we do is we actually submit both of these values to the blockchain, where it's then verified, and we say, okay, this was the same as what you originally told us, so now we're going to mark that player 1 chose scissors. Same thing here with player 2. We take the values, so rock and 373, we submit those to the blockchain. We make sure this matches what they originally submitted by checking the hashes of these values, and since it does match, we say we have scissors versus rock, and well, we know rock wins. I'm hoping this makes a little bit of sense, but this is how we do a little bit of kind of security on the blockchain and how we can reveal answers and store data without actually revealing what the answer is on the blockchain before we want to reveal it. Again, the reason we need to do this is we can't have one player submit their answer before the other player, because if they do that, then we're going to know what their answer is and we can always win. So what we do instead is we submit a kind of a secret string that has our answer encoded inside of it, but that we can only reveal once both players have submitted that secret string. So we have kind of secret string 1, right? So here, and secret string 2. And then once these are both submitted, now the players will tell us what their secret string was, and we'll be able to verify that what they're telling us is actually what it was. So both players have decided without seeing the other player's answer, and now they will reveal their answers, and we can end the game. Okay, that's the architecture here. Now, what that means is that we're going to have a little bit of logic that obviously can do this hashing from both the front end and the back end, and each player just needs to store their secret token for each challenge that they're participating in. We'll go through all of this and it will make a lot more sense, but that is the security implementation for this project, which I actually think is quite cool and shows you quite a lot about how we can make some more advanced systems. So let's hop over to the computer now, start coding some stuff out. We'll work mostly on the back end, then in future videos we'll handle the front end and do all of the interactivity. Alright, so we're back on the computer now, and what we're going to do is just set up a new folder where we're going to do all of our work from. So I just have open the same directory that we set up in the previous video, which is the rollups example. Now we're going to work inside of here just to make our life a bit easier. So I'm going to open up my WSL terminal. Notice that inside of this terminal, I am inside of the rollups example directory. What I'm going to do is I'm simply going to copy the the Echo Python directory, and I'm just going to make a new directory with a different name, and we'll start working inside of there for our project. So what we can do here is cp-r, which stands for recursive, and then echo-python, and then the directory we want to call this. So I'm going to say rock, paper, scissors, like that, and then I'm going to put a slash and go ahead and hit enter. Now if I type ls, we should see that we have a rock, paper, scissors directory. So now we can cd into rock, paper, scissors, and we can go ahead and build this application. Now to do that, let me just pop open my guide. Again, I always keep this open whenever I'm working just so I have all of the commands. So notice I'm inside of the rollups example and I'm inside of the new directory we just copied, which is rock, paper, scissors. And what I'll do now is I'll just take this command and I will paste it in here and I will build all of the Docker containers and images. Okay, that is built. Now if I want, I can go ahead and start my local node. I'm not going to do that this second because we don't need this started right away, but that's the basic idea. Okay, so let's close that up. And now if we go here, we should see that we have a rock, paper, scissors directory, and we've got a few files, okay? So we have echo.py, and we have pretty much everything that was inside of the other directory. What I'm going to do is go to echo.py, and I'm just going to rename this file to main.py. Just because I'd prefer it to be called main, I think that makes a bit more sense. I'm then going to go into the Docker file, and actually it says copy ... Okay, that's good, so we'll just leave that as it is. I thought we were going to need to change that. So fortunately, we don't need to change that. Okay, we have main.py. We can kind of leave this as is. I'm just going to get rid of this huge header comment so it doesn't block up our code. And we're actually going to make a new Python file. Now, this new Python file is going to be called challenge.py. And I want to begin by coding out a few different classes that are going to help us with the implementation of our backend. Now, these are just normal Python classes. There's nothing crazy going on here. And once we have this, we'll then go back and kind of code the Cartesi components, which will make this a bit more clear. So I'm going to go to the top of my program, and I'm going to import hashslib. Now, we're going to use this just for the hashing operation that I talked about previously. Don't worry, when we get to that point, I'll slow down a lot and explain it to you. We're also going to import time like this. Actually, don't remember if we need time or not. Actually, I don't think we do for what I'm going to do here, so I'll leave that. And I'm going to create a few classes. Now, the first class is going to be called move. Now, this is going to represent all of our different rock, paper, scissors moves. Now, we want to just use integers to represent them rather than strings. So I'm going to type none is equal to 0. I'm going to type rock is equal to 1. Paper is equal to 2. And scissors is equal to 3, just so we have an encoding for our different moves. So we're saying if we don't have a move, we'll just encode that with 0. If we chose rock, paper, or scissors, that'll be 1, 2, or 3, respectively. Next, I'm going to create an initialization here. So I'm going to say define init. I'm going to take in self. I'm going to take in a commitment, and I'm going to say move is equal to 0. Now what I'm going to do is just say self.commitment. If we can get the autocomplete going here, is equal to commitment, and self.move is equal to move. Now the idea here is that we're just going to have a class that will store the commitment and the finalized move for each of our players participating in a challenge. So the commitment is going to be the secret string, right? And the move itself will actually be what the move is from this commitment. But remember, when we first create the challenge and accept it, we're just going to have the secret string, and it's not until the players reveal their move that we're going to actually know what their move is. Okay, and we're just going to create a class method here. So we're going to say class method, and this is going to be defined move underscore to underscore string. And we're going to take in our class, and we're going to take in a move. And what this is going to do is simply return the string version of the numeric move. Okay, so we're going to say cls.none is associated with none. We're going to say cls.rock is associated with rock. We're going to say cls.paper is associated with paper. Notice I'm creating a Python dictionary here, by the way. You'll see why we want to do this in a second. And then cls.scissors is scissors. I'm then going to put my index, or in this case, key operator, and I'm going to put move. Now what this will do is it'll take in a numeric move that's between 0 and 3. It will then look for the corresponding value associated with the key in the dictionary. So I have none, which is 0, rock, which is 1, paper, which is 2, scissors, which is 3, associated with a string. When I access the index, this means we will return a string. And sorry, not index, but key. Okay, so that is our move class. Pretty straightforward. Now we're going to write the challenge class. Now this is where things get a bit more complicated. But this is where it's nice to be working in a language like Python, because we don't need to know the corresponding Solidity code to actually write the complex logic we need. We can write it in Python, which I imagine most of you are better at than Solidity. At least I know I am. So inside of here, we're going to create a init as well. And this challenge is what's going to store a lot of the information we need for an individual rock, paper, scissors challenge. And keep in mind, we can have multiple challenges, which is why we're creating a class so that we can have different instances of challenges. Now, the first thing we need when we create a challenge is the creator of this challenge. We want to know their address so we know what player is playing against what other player. We also are going to want to have an ID for this challenge so we know what the identifier is and how we can access it. We're then going to want to have the commitment of the creator, okay? So whoever first creates the challenge will submit a commitment, so that's kind of the creator's commitment. Okay, so inside of here, we're going to say self.creator address is equal to the creator address of the challenge. We're going to say self.opponent address is equal to none. Now, just like we have the creator, we're going to have the opponent. So we have like player 1 and player 2. I'm saying creator would be player 1, opponent is player 2. When we first create a challenge, it's open-ended. We don't know who the opponent is going to be, so we mark this as none. We're then going to say self.commitments. Now, this is going to be a dictionary that's going to store the commitments and really the moves for each of our players. So right away, we're going to say self.creator address is going to be associated with a move, which is the commitment from that player. So what we're doing is saying, okay, we want to make a new challenge. To make a new challenge, we need the creator address, the ID of the challenge, which we'll look at in a second, and the commitment from the player who made that challenge. We want to store all of these commitments so we can access them later. So we make a dictionary. We have the key, which is equal to the address of the creator or the address of whatever player it is in this challenge. And we associate that with an instance of this move class, which will store for us not only the commitment, but eventually what that player's finalized move is. So there we go, we make self.commitments. We're then going to say self.id is equal to _ID. If you wonder why I did _ID, ID is a reserved keyword in Python, so it's better to use underscore before just to kind of get rid of that reserved keywordness of this variable. Okay, lastly, we're going to say self.winner_address is equal to none. And I remembered why we wanted time, so I'm going to go back and import time here. We're going to go here and say self.createdAt is equal to time.time, just so we can store when this challenge was actually created. Okay, so this is how we initialize a challenge. We get the creator, we get an ID, and we get some commitment. Now, there's a few more steps we need to go through. So once we have a challenge, we need someone to be able to accept the challenge, right? So to accept the challenge, we're going to add an opponent to the challenge. So I'm going to make a method called addOpponent. And when we have that opponent, we want the address of that opponent. And we want the commitment of that opponent when they accept the challenge. So we take in the address and the commitment, and we say self.opponentAddress is equal to the address of our new opponent. And we say self.commitments at the address is equal to a move, and then we store what the player's commitment, kind of secret string, actually is. So very similar to what we did up here, but now we're just adding it into the commitments dictionary. Okay, so here is where it gets a bit more complicated. We are now going to write the function that will reveal a player's commitment. Okay, let's go ahead and write this. We're going to say define reveal, and we're going to take in self, address, move, and nonce. Now remember, nonce is that secret number that the player is going to store on their client, so they're going to store it themselves, and they're only going to submit it once both players have made their commitments, right? So once the challenge has been accepted, essentially, either player in any order can now reveal their move. So what I'm going to do here is I'm just going to start by saying if not, and this is going to be self.commitments.get, and then self.opponentAddress. Then I want to raise an exception here. So I'm going to say raise exception, and I'm going to say opponent has not committed. Now, the reason I'm doing this is I just want to make sure that the player who created the challenge is not able to reveal their move until they have someone accept their challenge and make that corresponding commitment. So that's what I'm doing here, just to make sure I'm checking that. All right, so now that we have that, what we're going to do is we are actually going to generate a hash of the secret key and the move that the player has submitted, and we're going to verify that that matches with their commitment string. So to do this, we're first going to have to write a function here. So we're going to say define generate underscore hash. Now this is going to be a static method because it doesn't belong to the instance, it belongs to the class. And we are going to say for generate hash that we are going to take some input and we are going to return the hashlib dot SHA-256, and this is going to be the input dot decode, sorry, not decode, dot encode, and then dot hex digest. Don't worry too much about exactly what this is doing, but we're using the hashing algorithm known as SHA-256, which is a very popular and common algorithm. We are taking the input, which is going to be some kind of string. We are encoding that to a hexadecimal value, and then we are getting the digest, otherwise known as the hash, from this function. Okay, so that is what generate hash does. Now what we're going to do is we're going to say the reveal underscore hash is equal to challenge, which is the name of our class, dot generate hash, and we are going to take the nonce and we are going to add the move to it. Both these values will be strings, sorry. This, I know I said it was a number. You'll see why this will be a string in a second, but either way, they're going to be strings. And if we wanted to really be sure, we could convert this to a string, or we could convert the move to a string. It doesn't really matter. Anyways, we're going to take the reveal hash here, and we're going to say if the, and we need to actually write this first. We're going to say committed underscore move is equal to self.commitments.get, and we are going to get the commitment from this address. And we are going to say if the committed move dot commitment does not equal the reveal hash, then that means that they tried to reveal an answer that was not their original commitment. So we're going to raise an exception, and we're going to say that the move does not match the commitment. Okay, so this is the main security thing, right? When they first create or accept the challenge, we take in that secret string. That secret string should be able to be generated by taking their secret number and their move and hashing it. So now what we ask them to do is, okay, submit your secret number and submit your move. When they submit both those values, we take them and we hash them. And if they equal what they originally submitted to us, that means they submitted the correct answer. If not, that means they submitted something that was not their original commitment. Okay? So now once they've revealed their answer, we can say self.commitments add address is equal to a move. We're just going to say the committed move dot commitment. And actually, now that I think about it, we don't need to do it like this. We can say self.commitments add address dot move is equal to, and this will be the int of the move that they submitted. So again, we verified that this move is correct. It's going to be 1 through 3, so either 1, 2, or 3. But remember, when we first create this move, we don't actually instantiate this, so it's equal to 0. So now that they've revealed their move, we store the move inside of the move class, which essentially means everyone now will be able to see what that is. Okay, then we can print something like reveal complete, just so we have some logging, so we'll be able to actually see that in our output. And actually, I don't think that's even going to log, so for now I'm going to get rid of that. I don't think we need that. Okay. Now that we have the reveal, that's kind of the hard part, but there's a few more methods that we want to write just to wrap this up. So first of all, I just want to have a method called both revealed. Now what this is going to do is simply just return if both players have revealed their move, because we need both of them to reveal their move before we generate a winner for this game. So we're going to say the opponent move is equal to self.commitments at the self.opponent address, okay, dot move. And we're going to say the creator move is equal to self.commitments at the self.creator address dot move. And we are simply going to return the opponent move does not equal move.none, and the creator move does not equal move.none. So all this is saying is, okay, both players have revealed their answer. And we know that's the case if they don't have a move equal to none. So that means they have a move, right? Okay. Now we are going to write another one here, which is define has opponent committed. And what we can actually do to check if the opponent has committed is exactly what we did up here. So I'm just going to grab this, and I am simply going to return that this does not equal none. And then I'm going to use this function here. So I'm going to say, where is this? If self.hasOpponent committed, and we'll actually put the not here. So if the opponent has not committed, then we'll raise this exception. I'm just making sure we don't have duplicated code by kind of fixing up some of these methods, okay? Now, lastly, we're going to say define evaluate underscore winner, and this is going to take in self. And what this is going to do is figure out who the winner of the game is. Okay, so first of all, let me copy this code here to get the opponent move and the creator move because we're going to need that. So what we need to check here is every possible winning case for rock, paper, scissors. There's a few ways to do this, but we can essentially write it in about 6 if statements. Bear with me here. The first one is going to check if rock beat scissors. Okay, so we're going to say if the creator move is equal to move.rock and the opponent move is equal to move.scissors, then we can say the self.winner address is equal to the self.creator address, right? Because they won. Otherwise, so elif the creator move is equal to move.scissors and the opponent move is equal to, you guessed it, move.rock, then the self.winner address is equal to the self.opponent address because they chose rock, player chose scissors. Next, we're going to check if scissors beat paper. So we're going to say else if the creator move is equal to move.scissors and the opponent move, if we can type this correctly, is equal to move.paper. Then we're going to say the self.winner address is equal to the self.creator address. Okay, let's scroll up. Otherwise, if the creator move is equal to move.paper and the opponent move is equal to move.scissors, then the self.winner address is equal to the self.opponent address. Okay, last one. This is paper beats rock. Okay, apparently I can't type that very well. We're going to say elif the creator move is equal to move.paper and the opponent move is equal to move.rock. Then the self.winner address is equal to the self.creator address. Otherwise, if the creator move is equal to move.paper and the opponent move is equal to move.rock. I did this in the wrong way, so let's fix these around, make this rock. This is very monotonous to type out. Okay, get rid of this. Then that means the opponent won, so self.winner address is equal to self.opponent address. Okay, chances are I messed this up, but that's fine. And then we're going to return the self.winner address. Okay, now notice that I didn't handle any draws. The reason I didn't handle any draws is because if the winner address is equal to none, that means no one won, and hence we can infer that that is a draw. So I don't need to explicitly say, oh, the game was a draw. I just don't declare a winner, and if I don't declare a winner, it means it was a draw. Okay, so that is it for all of the code we needed here. So we have evaluate winner, has the opponent committed, have both players revealed, we have our generate hash, we have our reveal, we have our add opponent, and we have our initialization. And then, of course, we have our move class. Now, we're going to use all of this from the backend, so that's why I wanted to write this first, so that we have this file kind of handled, and now we can just use all of these methods that we've written. Now, keep in mind, all of this code will be available from the link in the description in case you get lost, or in case, for some reason, something's going wrong. You can just go ahead and copy it. Now we're going to go into main.py. Okay, so in main.py, what I want to begin by doing is essentially defining all of the different types of operations that this code is going to handle. Now, this is how you should begin when you're writing any kind of decentralized application, whether it's with Solidity or Cartesi. You want to essentially figure out what's known as the protocol, and the protocol is what different operations can be performed. Now, remember that we have advance and we have inspect. Now, let's just start with a comment, and we want to start by figuring out, okay, what is going to advance the state? All right, what type of operations are going to require a transaction so that they'll be finalized and secured on the blockchain that allow us to modify the state? Well, the first thing is going to be create challenge, right? First thing we need to do. Next thing is going to be to accept the challenge. And then the last one is going to be to reveal our answer. These are the three things that we need to do. Create a challenge, accept the challenge, and reveal. That's really the core logic. Those are the three operations someone can submit to advance the state. Now, we also have inspect. Now, inspect allows us to get some specific data and inspect the state. There's a bunch of things we could write here, but what we can actually do just to simplify things quite a bit is just to get all of the challenges that are currently active, right? Or just get all of the challenges in general. We can make this more advanced if we want, but really what we want to do is create challenges, accept challenges, reveal, and then we want to get them. We want to view all of those challenges. We can, again, write some more specific inspect states if we wanted to get one challenge or get what challenge one player is in, etc. But for now, we're going to keep it nice and simple, and we're just going to use these 4 types of operations. So what we want to do is we want to essentially stub these out or write the functions that are going to handle these 4 operations. Now, notice we have handle inspect and handle advance. We'll get into those in a second. But for now, we're just going to stub our functions. So we're going to say create challenge, and we're going to put pass. We're then going to say define accept challenge, okay, and pass, and then define reveal and pass, and define get challenges, and oops, this needs to go here, pass. Okay, so we now have the 4 main functions that we're going to want to call. Now notice I've got this thing called handlers. Might look a little bit complicated, but I promise you it's not too complex. What this actually does, if we view down here, is it gives us access to the function associated with either advancing or inspecting the state. So we begin again by defining, okay, what type of operation are we performing? Is it an advance or is it an inspect? So we actually get that by viewing the request type, and this gives us access to a function object. We then call that function object with the data associated with this specific rollup. That's what's happening here with these handlers. Now we're going to do the exact same thing within these functions for the different handlers we'll have for our specific methods. So what I'm going to do is write some more handlers. I'm going to say advance method handlers, okay, and inspect method handlers. And we're going to use the exact same kind of type of architecture or design pattern here. So for our advanced method, we have 3 different operations we can perform. We could do a create challenge, right, which will be associated with creating a challenge because that's the function that will handle that type of request. We then have reveal. That will be associated with our reveal function. And we then have accept challenge, which will be associated with our accept challenge function. Now let's go to inspect. For inspect, it's nice and easy. We just have get challenges, which will be associated with get challenges. So we've just kind of mapped a string, which is really the type of request we're going to handle, to the function that's going to handle that request. So actually, sorry, before we do that, I realize we've got some code here that I don't want to just delete because we are going to use it, but I want to utilize it to write some helper functions. So my apologies, but we're going to do things a little bit different. I'm going to make a new file here, and I'm going to call this utility.py or util.py. Now inside of util.py, I'm just going to paste in 2 functions that are very simple that allow us to do some encoding and decoding so we can actually read what's going on. So I'm just going to paste these in here. Very straightforward, string to hex and hex to string. Feel free to pause the video and type them out, or you can type them out as I explain what they do. So anytime we receive data inside of our kind of main.py file here, so like data payload and all this stuff that we're going to look at later, it's going to come in as hexadecimal encoded. Now, that's not very useful to us because, I mean, I don't know about you, but at least me, I can't read hexadecimal data. So what I want to do is I want to convert that to a string. So the second function that we have here simply takes in some hexadecimal data, and it just converts it into a string for us. So it says bytes.from hex. This actually just gives us a string, hex to string. We then have string to hex, which does the complete opposite. Takes a string and converts that into hexadecimal data. That's because anytime we do data exchange here, so sending, receiving, it needs to be in hexadecimal, but it's just within our own code. We want to be working with strings and kind of printing out strings and logging strings because that's what we're used to using. So we just have these 2 helper methods, string to hex and hex to string, that help us do those conversions. So what we'll do now is we'll just import those from our main code so that we can use them. So we're going to say from util import string to hex and import hex to string. And while we're at it, we can say from challenge, import challenge, and import move, because we'll use those classes in a minute. Now, the reason I wanted to do those now is because you can see here that we have some code that adds notice and that adds a report. Now, eventually we're going to need that, so we might as well write some utility functions that will allow us to do these quite easily. So we're going to say define add underscore report. Now remember, the report is just some diagnostic information, kind of a log of what happened. So we'll just take some output that we want the report to be, and by default it could just be an empty string. Now for the report, we're going to take all of this stuff here, okay, and we're going to paste it inside. Now we don't need all of this, and we're going to modify it a bit. But the first thing we're going to do is we're going to say logger.info, adding notice, and we're just going to add to this whatever the output is so we can see what that is. Now, for our actual notice, okay, we're going to have payload, and then what we're going to do is we're going to take string to hex, and this is going to be our output, because the output's going to be of type string, but we need to convert it to hexadecimal before we put it in the notice. So we say, okay, payload is associated with the string to hex, like that. Okay, then we're going to have our response. The response is going to the rollup server plus /notice, that's just the endpoint. And then the JSON is simply going to be the payload that we have right here. And then we can print out receive notice status, blah, 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 with body content, this. Okay, great. So that is adding a report. Now we want to add a notice. And actually, I just realized this is adding a notice. It is not adding a report. So I messed this up a little bit. Fortunately, we can change this quite easily. So rather than add report, we'll just make this add notice. And rather than output, I'm just going to call this data. And I am going to make it mandatory here. And I need to change this now a bit. So rather than that, we're going to put data in an F string, just because the type of our data here may not necessarily be a, a string type. Okay. Anyways, I think this is fine for now. Adding notice, data, payload, string to hex. I'm getting a little bit confused, but I think that is okay. All right. Next, we're going to do our add report. So define add reports. And this time, we'll take output equal to an empty string. Now we're going to copy this code right here. Okay, and we're going to put this inside of add report. So now we can say add report plus the output. We can create our report. This time, for the report, we'll say string to hex, and then our output. And then I think that all of this is actually fine. So I think these functions are actually exactly the same, except one's notice, one's report. And I think I was just getting a bit ahead of myself on how this worked. But anyways, you have add report and we have add notice. That's fine. So what we will do now is go into handle advance and handle inspect and start calling the correct function based on the type of data we're receiving. Now, I understand this is a little bit confusing, so I just want to go all the way down here and kind of explain how we're going to handle this. So we're writing our own decentralized application. And as you've noticed here, we're pretty much designing the protocol, which is the way in which we want to interact with this application. Now we can interact with this any way we want, and we can send any type of data and receive any data that we want. Now I want to use JSON data because this is data that we're probably most familiar with. It's just like a Python dictionary. So what I'm going to expect is that I will receive a JSON object inside of my rollup data. Now this JSON object, I expect to have a key method, and the key method should specify one of the appropriate methods. So create challenge, like this, okay? This is what I'm expecting to accept as my data. Now this method will tell me what the user wants to do. Creating a challenge, revealing a challenge, accepting a challenge, or getting challenges. So I want you to keep that in mind as I write the next bit of code here. The data that this backend will accept will be a JSON object that will contain the key method. It may contain some other keys as well, but for now, method is what we're focused on. Okay, so if we go inside of handle advanced now, which is the one we can write first, the first thing we need to do is we need to parse the data we received as a JSON object. So to do that, we're going to say payload is equal to JSON, which we need to import. Okay, so let's import JSON like this. dot load s. This stands for load string. Then we're going to take the hexadecimal data and we're going to convert this to a string. Now again, I know a little bit confusing. Bear with me here. And in fact, I'm going to delete this because this is not going to be helpful to us right now. I'm saying payload is equal to json.loads. Now, the data that's inside of the payload, which is what we're actually sending to the backend, is going to be hexadecimal. So I start by converting that hexadecimal value into a string value. Now what we get is essentially a string, which is JSON data. What we want to do, though, is we want to take that string and we want to convert that to a JSON object, or in this case, a Python dictionary, so we can utilize it just like a Python dictionary. So that's what we're doing. But the thing is, this could fail because we might not actually be receiving JSON data if someone sends us something invalid. So I'm just going to do a try except, and I'm just going to return reject here. When you return reject, you're essentially indicating that an error occurred. That's all we're doing, okay? So we're saying, okay, try this, generate a payload. If the payload doesn't work, we're just going to return reject and kind of indicate, hey, whatever you tried to do here did not work. Okay, now if we did actually load the payload, what we want to do is get the method that's stored inside of that Python dictionary. So we're going to say method is equal to payload.get and then method. Okay, now what we'll also get at the same time is the sender. Now the way we get the sender is we say data, metadata, and then message underscore sender. Now again, what we're passing here, data, which we'll look at down here, right? So rollup request data is going to contain a bunch of different keys. There's some more documentation that shares with you everything, but it's going to have a payload, which is what we want. And it's also going to contain who sent this. So what address actually sent this request. So that's what we're looking for, message.sender. So we have the sender. Now what we can do is we can say logger.info, and we can just put an f string here, and we could say received advance request data. And then we can log the payload, which now will be in an object format that we'll be able to actually read. There we go. Okay. Now that we've done that, we just want to check this method and make sure this method is inside of the request handler. So what we can do is say handler is equal to advance method handlers dot get, and then we can attempt to get the method. Now if we say if not handler, so essentially that means if we did not have this method inside of the advanced handlers, what we can do is add a report, okay? And we can say invalid method, indicating to the user, hey, this was invalid. And we can return the string reject because, well, this didn't work. Otherwise, what we will do is we will return the handler and we will call this with the payload and the sender. Okay, so this is handle advance. We are loading in our JSON data. We are getting the method that the user wants to call, as well as the sender of this message. We then are making sure the method is valid. If it is, we're going to call that method by looking at the associated handler, right? So we're going to call that function, and we're going to pass that function a payload and the sender. Okay, so now what we can do is we can just kind of fill in these three functions here, and we can just generate something like a report inside of here, just so that we can actually test if this is working using our front-end console. So what we're going to do for all of these is we're going to say payload sender, because that's what we want to receive, and payload sender. We're going to return except, okay? So we're going to return that from all of them. Okay, and for now, we are going to say, what is this? Generate report, or what is this? Make report. What did I call this? Add report. Okay, only one I didn't try. Add report, and we're just going to say create challenge like that. For this one, this will be accept challenge. This is just for testing purposes so that we can actually run this code. And this is going to be reveal challenge. Okay, so now we have everything handled and kind of hooked up for advancing. Obviously, there's some more stuff that we need to write, but the core logic is kind of there in terms of taking the request and routing it to the correct location, which is what we just set up. So now that we've done that, we'll pretty much repeat that process and do the same thing for the inspect. So for inspect, we can really just copy all of this, and we'll just modify it a little bit. So go to handle inspect. Okay, we're going to load in our payload. We don't actually care about the sender. and we're going to change this to say received, and this is going to be inspect request. Now, rather than advance, this is going to be inspect method handlers, and then here for the handler, we will just call this with our payload. Okay, so that's pretty much it. That's the exact same thing for inspect. We get the payload, we get the method, we make sure the method is valid for the inspect request type. If it's not, we have a report. Otherwise, we do the handler. Now for get challenge, that means that we're going to have to take in some parameter. I mean, we don't have to. We actually could not pass the payload if we don't care about it. So we can just do this handler. And now we don't actually need to take anything inside of our get challenges. Okay, so that's all hooked up. Let's do the same thing here and return accept. And let's add a report that says get challenges. Okay, everything is hooked up. We have all of the routing done. Let me just zoom out a bit so you guys can read more of it at once. Kind of slowly scroll through, and you can pause it if you need to have a look at it. Again, remember all of this code will be available from the link in the description. And we haven't changed any of this. We've just been kind of handling routing our different requests. So now that we've got that, we want to actually run our code, and we want to try this out to see what happens and if our requests are being routed successfully. Sorry about the sudden cut there, guys. Anyways, now that we have all of this code written, what we want to do is start setting up the environment so we can actually execute and just do a bit of testing. Now that'll wrap up this video, but let's get everything running just so we know it's working. So first things first, make sure you have Docker desktop running. Okay, if you don't have it running, none of this stuff is going to work. So make sure you have that running in the background. Then what we're going to do is open up our WSL window, but first we're going to make a modification to a few files here. So if we look at entrypoint.py or .sh, sorry, you can see that we have echo.py. Now that was the name of the file we changed to main.py. So we're just going to change this to say main.py. Now we're going to go into our DApp.json, and we're just going to list all of the Python files that we have now. So rather than just echo, it's going to be main.py, util.py, and challenge.py. These are the files that we need to copy in for our code to work. So we're going to put those three here. So those should be the only modifications that we need to make, again, in dapp.json and entrypoint.sh. Now we're going to go over here and start setting some stuff up. Now I'm just going to open up my developer guide here because this is always quite helpful. So first thing we got to do is work on our node. Now for our node, we need to build the project so that we have all of the correct Docker containers. So I'm going to copy this command, docker build x bake load. I'm going to paste that here in rock, paper, scissors. Okay, so I'm going to go ahead and hit enter. Give that a second, and this should build all of the necessary containers we need, and you should see this run without error. If you are getting any errors here, make sure that you change those files I just showed you so we copied in all the correct files to the image. Now, if you're still having issues with this, what I would recommend you do is ensure that you tore down your containers correctly and that you cleared any of the cache that you have in Docker. A lot of times what will happen is Docker will actually cache some previous containers, volumes, etc. And when you try to run this command, it will use some of those containers and there'll be some mistakes because they weren't spun up or torn down correctly. So what you can do is simply go to your Docker desktop, you can view all of the different containers, and then you can delete any of the ones that currently exist, as well as deleting any of the volumes. Then you can rerun the command and you should be good to go. Before you do that, you can also just run the command that takes down all of the containers, so the docker compose down command, the one that is in the Cartesi guides that are linked in the description. Okay, now that we've built that, we're just going to spin up the test node, right? So we're going to copy that command we used in the previous video. Just make sure the, what do you call it here, the line breaks are correct, so we'll fix that one. Should spin everything up, and we just want to make sure this runs and give it a second so that it doesn't have any errors, right? So it's deploying all the contracts. Okay, looks to me like that is fine. Now in our other terminal window, so let's bring one up here, we're going to start initializing our virtual environment. Now you may have copied the virtual environment already. If you didn't copy the virtual environment from the previous video, you're going to need to make a new one. So let me just open up the guide here on the left hand side of my screen, and you can see that to make a new virtual environment, it's this command. If you already have it though, so if you ls, and again it's not going to show it because that's a dot, but there is a .venv folder, right? So if you see that in your VS Code, you don't need to remake it. And what you can do is just activate it. So I'll copy the command here to activate the virtual environment. If that doesn't work, then make the virtual environment first with this command. Then install the requirements. We should already have them installed because we have the same virtual environment. And now we can create or spin up our backend. So what we're going to do is copy everything, but not the echo.py. And then for the file, it's going to be main.py, right? We don't want to run echo.py. We want to run main.py because that's what's going to actually execute our code. So let's go ahead and hit enter there. That should spin up our server. And yeah, we can see that it's running here. Okay, so now that we have that, what we can do is go into VS Code, and we can start using the front-end console to just send some requests to the server so that we can make sure that our code is working. And we're just testing the routing at this point. In the next video, we'll get into some more of the deep logic. So from the rollups example directory, we're going to go to the front-end console. Okay, let me just clear that. Remember that we want to type yarn just to install everything. So I already did this in the previous video, but type yarn, we're going to get everything installed. And then once it's installed, I will show you how we can send some inputs and some inspect requests and just make sure that we're getting the correct reports and outputs. Okay, so what we can do is just open up the guide here. And for the guide, it shows us how to do this. So yarn start input send, and then we can send something like a payload. So I'm going to copy this into here. Okay, let's make this a little bit larger. And for the payload, we actually want to put a string, which is the JSON data. Now we need to be a little bit careful here because the quotation marks can mess this up. But I'm going to put double quotation marks, or actually, I'm going to put single quotation marks, sorry. I'm going to put an object because we're going to send JSON. And I'm going to specify my method. Now make sure you're putting this inside of double quotation marks because we're essentially writing what the string is that we're going to send over to this backend. Now we'll know quite quickly if it's not working, but we're going to put method. And for the method, we will go with create underscore challenge like that. Okay, now notice we have double quotes inside of the single quotes. Go ahead and hit enter. Give this a second. We should see it popping up here on the right hand side once it actually gets sent through. All right, so we got an error here from the front end console. Now I think that just has to do with my quotation marks. So I'm just going to put double quotation marks, and I'm going to start putting some escape characters here. Just bear with me for a second because sending JSON is not really supported in the front end console, but we're trying to do it for testing. We'll write our own kind of tool later, but I just want to see if this is going to work now and actually send the JSON over, and I'll kind of do a few attempts. Okay, so it looks like that did work. It says sending method and transaction input 0 added. However, we did not see anything appear over here. Okay, there we go. We just got it. Received advanced request data, method create challenge, adding report create challenge, receive report status, sending finish. Okay, so that means that worked. I just wanted to test the communication here. And to kind of explain how this worked, we had our double quotation marks, which is the string. We then put inside of here our JSON data, and I just escaped the double quotation marks with an escape character, which is the backslash, okay? So by using that, it's the backslash / I forget which one you call this, but whatever this direction slash is, we escaped these double quotation marks, so we're able to embed double quotes inside of these double quotes for our JSON data. Okay, so that was one. Now, other than create challenge, we want to test all our routes. So we're going to test accept challenge. Okay, so this is going to be an input. Send that over. Give this a second, and we should see it respond to this in a minute. Okay, and there you go. Accept challenge came in. Now we want to test reveal. So let's go here and test the reveal. And then next we will do an inspect request, and we will test the, the get challenges. Okay, so input to added. Give this a second to respond, and there you go. We got reveal. Okay, incredible. Now that we have that, we can have a look at some of the notices or the reports that have been created. So again, we can go back to our guide here. We have yarn start notice list, but I believe we can also replace this with report. So we'll say yarn start report list. See if that gives us a list of reports if I typed that in correctly. All right, I was getting some weird error there because my TypeScript's all messed up on my computer. Anyways, for you guys that should have worked, but I'm going to type yarn start inspect -- payload, and then we'll do kind of a similar situation here where we have method get underscore challenges. Don't worry too much about this tool, guys. I'm just using this for testing purposes. We're not going to use this in the production application, obviously. It's just kind of a debugging tool. But if I send this, I think this should work if we send the payload correctly, and it returns to us get challenges and would give us any reports or whatever that were generated. And you can see here it says received inspect request data, get challenges. There you go. And there's one report that has get challenges inside of it. Okay. Anyways, that is it for this video. I just wanted to get the core of the backend done, a lot of the communication finished. So this way in the next video, we can handle the logic in those functions and then start working a bit on the front end and kind of getting that set up and stubbed so we can then wrap that up in the video after that. Anyways, I hope you guys enjoyed so far. If there are any questions or if you're having trouble or if for some reason you need to reference the code, please, you can look at the links in the description. We have the Cartesi Discord server and you can obviously reference all of the complete code. Anyways, I will see you guys in the next video.